Today we're going to get into quadratic functions. Quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a does not equal 0. So there's going to be some x squares. Anything to the second power becomes a quadratic equation like that. And this is in the standard form of a quadratic equation. Ax squared plus bx plus c. Now eventually we're going to be graphing these things, and boy oh boy is that a treat. Today we're going to be solving some equations. So here's what we got. The graph of a quadratic function is a U-shaped curve, and that curve is called a parabola. 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 You can fold a parabola so that the two sides match exactly. The fold or line that divides the parabola into two matching halves is called the axis of symmetry. So it's the line that splits it perfectly in half. Symmetry. When two things are symmetrical, it looks the same on both sides. The highest or lowest point of the parabola is called the vertex. If a is greater than 0, aka if a is positive, if you have a positive number in front of the x squared, the parabola opens upward like this. The vertex is at the lowest point, and they call that lowest point the minimum point. Minimum. But if a is greater than, or if a is less than 0, if a is negative, it's going to make that parabola go upside down. So the vertex is at the top, and they call that the maximum point, which makes sense. If you had to guess which one is at the top, maximum or minimum, you would guess the maximum, right? That's the highest point. Also, it kind of looks like maximum. All right. Identify the vertex of each graph. Tell whether it's a minimum or a maximum. So the vertex is the point where it starts changing directions. On this graph, it would be right here. The location of that coordinate, it's 1 to the right, it's down 2. So our vertex is at 1, negative 2. Now, it's opening upward. This vertex is the lowest point. So is that a maximum or minimum? If it's the lowest, that means it's a minimum. Cool. We look over here. Oh, this is for you to try. Identify the vertex, tell whether it's a minimum or maximum. You'll see where it starts changing directions. This highest point here is at negative 2, 4. And that is the absolute highest point of the graph, which means it is a maximum vertex there. And remember, this one opens downward. That means that a, the number in front, would be negative. Here it opens upwards. That means a would be positive. What else we got here? Notice on these problems you have an x squared, but there is not an x by itself. When that's the case, you can solve by taking the square roots. So if you look at example 2 here, x squared minus 25 equals 0. There are no just standard x's. So we're going to get the squared stuff by itself. Now, if that was just x minus 25 equals 0, no problem. You would just add the 25. And that is going to be our first step. We're going to add 5 to both sides, or 25 to both sides. X squared equals 25. Now, remember when we're solving equations, we're always doing the inverse operations to cancel out the opposites, right? The opposite of squaring something is square rooting. So we are going to square root both sides of the equal sign here. Now, when you square root 25, your calculator is just going to tell you 5, because 5 times 5 is 25. But also, negative 5 times negative 5 is positive 25. So if you're square rooting a positive number, you have to include the positive and negative roots of that. It's an easy way to do it. You could write 5 and negative 5. Otherwise, you could just write plus minus 5. That means positive 5, negative 5. That's probably the easier way. Isolate down to whatever's being squared. So on example 3, First, we would get rid of the plus 12 by subtracting 12. 3x squared equals 12 minus 12 is 0. We still got to get it down to the x squared. So we would divide both sides by 3 here. 0 divided by anything is still 0. Now it's x squared equals 0, so we square root both sides. Usually you would say plus or minus, but there's no such thing as negative 0. Right? You can't, so it would just be regular 0. No negative 0, not a thing. So if you're square rooting a positive number, you put the plus and minus. If you're square rooting 0, you don't need to. It's just 0. Let's look at example 4. 3x squared equals negative 27. So you would probably divide by the 3 first. X squared equals negative 9, and then you would square root it. Now, if you type in the square root of negative 9 in your calculator, it'll go, syntax error, or something like that. You can't square root negative numbers. So if that's the case, you're going to say, no solution, no real roots of negative numbers. When you get into Algebra 2, we kind of use a different system called the complex number system, and then we are able to square root negative numbers. But in Algebra 1, we can't do it. So here's one for you to try, but we're going to just go over this together. 5x squared plus 13 equals 68. We'd obviously get rid of the 13 first. We'll subtract it. 5x squared equals 68 minus 13 is 55. All right. Then we could divide by 5. X squared equals 11. And then here's where you would square root both sides. So we could say x equals plus or minus, and then let's see what the square root of 11 comes out to. 3 point something. 3.3166247, and then it rounds it at 9. So we could say 3.32. Boom. Look at us square rooting. That was fun. What a good time. Oh, when a quantity is squared, we're going to isolate that quantity first, and then we'll square root like we've been doing. So if you look at example 2 here, we have x plus 1 squared plus 8 equals 72. We want to get it down to just the x plus 1 squared. So we'd have to get rid of the plus 8. Obviously, we're going to subtract the 8 on both sides. X plus 1 squared, 72 minus 8 is 64. Now we're going to get rid of the square by square rooting. Now remember, the square root of 64, your calculator would say is 8, but it could also be negative 8. So if we still have more to do, we're going to set up 2 equations. We're going to set up x plus 1 equals 8, and also x plus 1 equals negative 8. We have to include the positive and negative roots. It's kind of similar to when we did absolute value equations. You set up 2 equations there. And then we just have to subtract 1 from each of them. X equals 7 and x equals negative 9. If you put in either of these into the original equation, they both work. Let's try negative 9. Negative 9 plus 1 is negative 8. Negative 8 squared is positive 64, plus 8 is 72. 7 also works. All right, so there's 2 here for you to try on your own. We're just going to go over them. Isolate the squared stuff first. So here we would divide both sides by negative 6. M plus 5 squared comes out to 81 over there, positive 81. So then we'd square root it. Square root of 81 is 9 or negative 9. So m plus 5 equals 9, or m plus 5 equals negative 9. And then on both equations we could minus 5. M equals 4. And over here, m equals negative 14. Great. All right, it looks like this is the last one. Of all of them? Yeah. All right, we'll subtract the 2. 10 times n plus 4 squared equals 250. Now you gotta get rid of that 10 out in front. It's 10 times stuff. So we'll go ahead and divide both sides by 10. N plus 4 squared. This comes out to 25. We're going to cancel out the square by square rooting. 25 could be 5 or negative 5. So n plus 4 equals 5, and n plus 4 equals negative 5. Last step, just minus 4 on both sides. 5 minus 4 is 1. Woo! Barely made it. And negative 5 minus 4 is negative 9. Sick? Sick. All right, that's it for today, dudes.